Hello and welcome to That Fabric Guy. My name is Bas Land and I will be teaching you every week about Microsoft Fabric. And today we're going to look how we can execute DAX queries across the Power BI API in order to store data from a Power BI semantic model in your Fabric Lakehouse. Now that is very difficult. Why would you want to do that? You want to do it probably for the Fabric Capacity Metrics app, because that is an app that shows you all kinds of information about the usage of your Fabric capacity. And it is a semantic model. The underlying data source, a CustoDB, is not available. You cannot access the underlying data set. So if you want more than just the 14 days of history that Microsoft gives you, you have to find a way to store that data yourself. And since you cannot access the underlying database or the APIs, you have to query the semantic model that Microsoft gives you through DAX queries. And today we're going to look at how we can do that with a very simple example. So let's dive into my laptop and find out what we can do. Alright, so this is my Fabric Capacity Metrics app, and don't mind the error message that is popping up on the top right side. Microsoft is having an outage today, and parts of Fabric are completely wonky due to that. So let's see what we can do here. We have the Fabric Capacity Metrics app, and when we click on Edit, we can actually find the data model or the tables and the columns and so on that are available in this table or in this model. Now, a couple of these are very interesting to us. If we start clicking on objects, we can find what type of objects are being used. We have the measures table, of course, but we also have an items table. Now, in items table, we find the item kinds. Is it a warehouse, a Synapse notebook? Is it an LLM plugin for Fabric data agents? And so on. Now, the tables that we see here are very interesting, and in practice, I would like to have all of those tables materialized on a lakehouse in my own Fabric capacity, so that I can look farther back in time than just the 14 days that Microsoft is giving me. So today is Tuesday, January the 20th, and I can look back until Wednesday, January the 7th, and no more than that. So we're going to look at how we can actually store data one at a time. Let's look at the items table, because the items table is an easy table to demo. It's a small volume table and it speaks for itself on what we can do there. Now, before we start, there are a few things that we need. We need the Fabric Capacity Metrics app semantic model, and we need the group and the dataset ID. All right, let's go into a notebook, because with this PySpark notebook, we are going to create our connection to the capacity metrics semantic model, and we're going to execute DAX queries against that model and then storing that data in a lakehouse. First of all, you need to set up your connection. So we need to import the requests library in order for us to do an API request against the Power BI API. And then we get a user token. We do not need an app registration or a service principal. We can use those, and we want to use those if the user that is accessing Power BI is not the same user that is executing the notebook. But in this case, we can do the short route, the easy way, because my user has access to both the semantic model and is running the notebook. So we can use a library called Notebook Utils by Microsoft, where we get a token based on my current user credentials by calling the Power BI API. The token is then being used to set up the API connection further in the notebook. Secondly, we need to set some constants. We need to set the dataset ID and the workspace ID. Then I created two additional constants, the source table and the target table, which is, I'm looking for the items table in the semantic model, and I'm putting that in a table called staging_items. I'm going to explain why in a minute. Then here we have the heart of the notebook. This is still a very easy cell. It's only a little bit of code. It's very readable, but this is the heart of the notebook where we will be actually executing our DAX queries. First, let's set the URL, and the URL here is just a string parameter or string variable where we call the api.powerbi.com for a certain group, which is the workspace ID, for a certain dataset, which is the dataset ID, and then we call the execute queries API. In order to actually be allowed to call the execute queries API, we need to pass a header containing an authorization token, a bearer token, which is the token that we just created in the first cells in the notebook. Then we need to create, we need to create a DAX query, and the DAX query is just a piece of text that we then can execute. So the text in here that I'm going to execute is evaluate, and then a new line, and then a source table. So evaluate items in this case. Evaluate is the DAX equivalent of select star from in a SQL statement. So this will just return all of the columns, all of the rows that are visible for me in this table. I'm going to create an object called payload, and payload will contain the DAX query that we are about to send. I will then create the call to the API using the requests library. The post function in here is used because we are doing a post method to this API, and we're posting against the URL containing these headers that we just created, containing the payload that we just created in here. And then we get the results and we transform those results to a Spark data frame. So we create a variable called rows where we fetch the result from our API call. And then we create a df, a data frame, where we say spark.create data frame for this rows object. And then we can display the object. We can write that object to a target table. Okay, let's see how that works. So we start the session here, we get a token. Now, if we were to print the token, that's actually quite interesting, it will be redacted. So the token itself will contain the actual key that we need to call the API. However, because this is a security token, it's an authorization key, we cannot actually visualize this. Okay, so this is safe. This will not end up in your logging or whatsoever. It will be redacted in any client application. So let's remove that. Let's execute our constants cell, and mind you, every time we start changing the table names in here, we need to rerun this cell. That makes sense, right? Then we're going to execute the DAX query, and this might take a little bit longer. It's just 1.5 seconds or 1.6 seconds in this case. And that the reason for that is that it is actually executing the call against Power BI API and getting results back. Now, if you query a larger table, this cell might take a little bit longer, depending on how much data needs to be transferred across the line. Let's visualize the data frame that we just created. Using display df, we can actually visualize the Spark data frame. So in here we see that we have a lot of information on the different items that are in our Fabric capacities. So we all the way on the right side we have the capacity ID. There are actually two capacities in my tenant that I have access to. We have workspaces, we have workspace IDs, timestamps, the key, which is I think a combination of capacity ID and item ID. Then we have the item kind, is it a lakehouse, a dataset, a notebook, and so on. We have the item name that the user gives to that name. We have whether the item is executing billable operations against whether the object is actually, or whether the item is actually executing billable operations against our capacities and so on. So this is a very nice dimension that we will be using if we start rebuilding the semantic model for the capacity metrics app. That's not what we're doing today. Today is just all about how can we store the information that we're getting from a DAX query. Okay. So when we scroll down, we have this cell in here where we say df.write. We're going to write the data from our data frame in a format called Delta. I've published quite a few videos on the Delta storage mode already. And oops, Control Z, and we have our override mode. The reason we're overwriting is this will just be considered a staging table. And every day that we run this notebook, we will dump a set of 14 days of data on this table, and in the end, if we are actually going to rebuild this this data model, we will probably be using a staging table and then merging that into our actual historical table. All right, so let's validate that we don't have any tables in the bronze lakehouse whatsoever. We don't. Let's execute this query in here. I say query, but I mean we're executing a cell in the notebook, of course. And we run into an analysis exception. There's okay. I did not prepare this demo in advance, as you can see. The one thing that we need to figure out here is there's in some of the column names there's spaces, and we need to take those out. And actually what I am going to do, there's table name and then column name on every header here. What I'm going to do is I'm going to give you a piece of code that you can strip everything that's within the square brackets and just give you the name that's in between here. And we will put then those names together. So we will replace the spaces with an underscore, and then we should be all right. All right, so I added a little piece of code here. I wrote this for loop for every column name that is in my data frame. I will be doing three things. The first thing we're going to do is we're going to extract the text between the square brackets. And the second thing we're going to do is to clean the name, replacing spaces with an underscore. The third thing we're going to do is that we are going to rename this column name with the clean name. Now let's execute this cell in here to run the data frame again. That's done. Let's now run this cell here again. There we are. And we see that we now have readable names without brackets, without spaces. So billable type is now billable underscore type, and I don't see spaces anymore. So that's actually good. And now we should be able to write down our target table to the Lakehouse. There we go. The table has to be created the first time around. So this takes a little bit of time, and it has been done right now. So we should be able to refresh the tables view here, and we end up with staging underscore items. So that's it. I hope you liked this video. Don't forget to give me a subscribe, and I'll see you next time.